Hi, my name is Bronna Butler. I've been a professional artist for the past 23 years. I have a bachelor's degree in art and a master's degree in accounting and finance from the University of Missouri. I work in stained glass, oil and pastel paints, graphite, stainless steel, and recently a bit of electronics. I have designed and painted over 900 square feet of stained glass windows in various buildings. I designed and managed the fabrication and installation of a 20-foot tall stainless steel monument with 4 colored titanium photomontage panels. And I have painted hundreds of commissioned large and small oil and pastel paintings. The largest single oil painting was 8 by 12 feet, which I painted standing on scaffolding. Since 2015, my muse has been mathematics. My current work focuses on recreational mathematics, puzzles, enigmas, and optical illusions, as well as mathematics and science in general. Beginning in February 2020, I have had the wonderful opportunity to collaborate with a team of 23 mathematical artists and artistic mathematicians who are creating a large multimedia art installation called Mathemalchemy. It celebrates the creativity and beauty of mathematics. It is the vision of mathematician and physicist Ingrid Daubechies. With the help of artist Dominique Ehrman, Ingrid has guided the collaboration on the large installation for the past 10 months via Zoom. After its completion in 2021, it will be installed in various museums and other places and then be permanently installed in Duke University's planned new mathematics building. The installation includes a 7.5-foot tall stainless steel lighthouse, which will stand on a 2-foot tall base. I fabricated the stained glass dodecahedron beacon for the lighthouse. The stainless steel lighthouse was designed by physicist Sabeta Matsumoto, and it will sit at one end of the installation. As a functioning real lighthouse would, the dodecahedron beacon will have Fresnel lenses to focus the light, in this case from an LED, shown here on our workbench. The glass dodecahedron will fit on top of the lenses and LED. In September, Ingrid introduced the group to an article in Quanta magazine regarding the discovery of something new about the dodecahedron. American Mathematical Monthly had published Mathematicians Jayadev Athreya and David Aulicino's proof that there exists a geodesic trajectory on the dodecahedron from a vertex to itself that does not pass through any other vertex. This can be shown with the unfolded net of the dodecahedron's pentagonal faces. Our lighthouse subgroup was unanimous. The installation's dodecahedron beacon should reflect this discovery. I downloaded the net shown in the Quanta article to use as a pattern. I lightened the areas of the pentagonal faces on one side of the line. Then I constructed a paper model which was clearly interesting visually. I made patterns from the net, drew them on stained glass, and cut the glass pieces shown here on my light table. The asterisks on this image of the glass pieces show the 2 vertices that will meet when the dodecahedron is assembled. Athreya and Aulicino, joined by mathematician Patrick Hooper, determined that an infinite number of such paths exist on the dodecahedron. Their paper, published in May 2020 by Experimental Mathematics, shows that these paths can be divided into 31 natural families. I illustrated one of these straight paths on the dodecahedron beacon for the Mathemalchemy lighthouse. The beacon will be 9.5 feet higher than the viewer, so I wanted to emphasize the path. To do that, I put crimson glass below the path and amber glass above the path. This is the vertex where our trajectory begins. It passes across the faces of the dodecahedron. See, this is the copper foiled path. It just misses this vertex, goes below it, comes around, comes back, and back to the original vertex without having passed through any of the other vertices.